Hey everyone, this is my channel here, and today we're going to be going through the binomial distribution, right? So a binomial distribution occurs when you have multiple Bernoulli trials, and I guess that's sort of the best way to put that. And as you get the data of a Bernoulli trial, as we've done in the previous video, and as you do it that many times, you will observe a distribution, kind of like the bell curve analogy that you may be familiar with. Right, so the properties of a binomial distribution is that there are n trials, so integers, how many trials you can't have half a trial, obviously, so n, where n is z, positive integer. These trials are independent, so a trial independent means the probability of success of a trial is not affected by the probability of the previous trial, the success or failure of the previous trial. And in the trial there's going to be two options, which is a success or a failure. And the notation is NCX or NCR, where it's like so you have this the other notation here, the brackets, and it's calculated using this formula. So NCX as the analogy, or NCR, it's n choose r. So if I have 12 things, and I want to choose 5 of them, how many ways can I choose 5 of them? You would do 12 C 5, 12 5 here. You would calculate it using this formula, and the exclamation sign is a factorial. So for example, you multiply an integer with the previous integers beforehand. So if I have 4 factorial, that's 4 times 3 times 2 times 1, and that's 24. Same thing with 5 factorial, so it's 5 times 4 times 3 times 2 times 1, and that's 120, something like that. But like the point is, you multiply all the integers beforehand. Here's a fun fact that would mean that the normal way that there's another analogy about deck of cards being 52 factorial. But you can search it up in your own time if you're really interested to find out what that means. So yeah, it's wrote down here, n trials, n is trials, number of trials, and x is the outcomes, the amount of favorable outcomes that you want. Moving on here. Right. Okay, so if x is a discrete random variable with a binomial distribution, yeah, if that's the case, then you write it as x in the notation of x. That's squiggly line binomial NP, where n is the number of trials, NP is the not success, but probability of success. That's a slightly different thing. Yeah, and if you want to calculate the probability of x, of whatever 1, 2, 3, whatever, etc., so you would have this formula here, NCR. So how many ways you can choose it? And this part here, 1 minus p raised to n minus x dx, where x is z, so x is an integer. Breaking this down. So the first part is how many ways you can get the answer you want. So it's NCX. This part here, let's say for example, P is like that probability, so like, I don't know, a quarter or something. And if I say I have a certain chance of getting this, and this is, and the probability of getting is a quarter, you'll calculate that as P is a quarter, that sort of thing. So you have 1 minus P, so P is the probability of getting it, and 1 minus P is the probability you're not getting it. It's probably the easiest way, so that's why I have x here, and n minus x. That sort of analogy. Next we'll be moving on to the very last part, which is the mean and variance of a binomial distribution. So as we said before, variance is a sort of spread of data of the binomial distribution, so how skewed or steep it is, or how flat. And mean is just the average value. And what it's saying here is that if x is in the notation x squiggly line, a binomial n dash n comma p, then the expected value is actually the mean, which is calculated by multiplying the number NP, so number times and the probability, associated probability. And from that you can get the variance, so spread, so sigma squared equals NP multiplied by 1 minus P, and from that you can get the formula for standard deviation, which is sigma equals the square root of the variance. And yeah, that'll be all.